Hey everybody, I am Ardalis. Go by that name online because Steve Smith, my real name, is really hard to get. Today we're going to talk about clean architecture with ASP.NET Core 10. I've been talking about clean architecture for quite a while, many years now. But every year there are some new things that I learn and new features that come out with .NET Core and ASP.NET. So I like to give this presentation whenever I have the opportunity and hopefully help some people learn how to structure their applications in a way that's appropriate for that application. Now, if you have seen some of this from me before, I do want to let you know I have some new stuff, so stay tuned till the end. And I do apologize, I only have like 29 minutes, so I'm going to go pretty quick, but it will be on YouTube later, and you can always slow it down or repeat it there. And one new feature that's in .NET 10, if you haven't seen it yet, is this cool feature where you can use DNX to run stuff. So I made a little business card that you can run at DNX-Y Ardalis card, as you can see on the screen. So check that out if you want to learn more from me in the short term. All right, so let's talk about architecture. And the very first rule of architecture is that everything in software architecture is a trade-off. And this comes from the very good book, Fundamentals of Software Architecture. And I've found it to be certainly true in all the different choices that you have when it comes to how you design your system and what type of architecture you're going to use. And clean architecture is no different. Now, this law is basically a fancy way of saying it depends. And it depends is, something that every consultant should probably readily say to most questions that they're asked. And the reason why it depends and the importance of this answer is what the context is. What is the things that are variables that it depends on, right? Because context is really king here, and your application's architecture should be designed for the kind of application and the kind of organization that you're building and that's building it. So, questions like, what are you building and who are the users and how many will there be? And things like, what's the performance that you'll need? How much data will there be? What does your team know and what's their experience level? And many, many more. Now, in that book, the authors talk about a lot of different capabilities of different types of architectures. And so these are the things that you kind of trade between one architecture and the next. So these are things like how modular is it? What's the overall cost to build it? How complex or simple is it? Is it particularly testable? Is it great at scalability, or is it good for performance? And all of these things can be trade-offs when you're choosing an architecture. So there's a little bit of background that leads into clean architecture that I want to share, because I know a lot of our developers today weren't around necessarily when some of us more experienced developers started their careers. And so let's talk about what was the context that kind of made clean architecture a thing. And I want to start with the 90s, because that's when I first started writing professional software in the 1990s, in a different century. And the primary way that enterprise software was being written at the time was an architecture called client-server architecture. And generally, the client was an application that you were building, and the server was a database server. And databases were these big, expensive things. They were expensive to purchase, to deploy on expensive hardware, and to maintain and back up. And as a result, a lot of organizations, they didn't have a lot of these things lying around, right? They had a database server, at least a production database server. And so typically you would see most applications in an organization, even a large organization, would write applications to talk to the same database server. In fact, in many cases, they would be talking to the same database. Now, this did have a positive effect of being able to say that anytime one of those applications makes a change, like they update the customer's phone number, that all the other applications can see that change for free. But there are other trade-offs here, because again, everything is a trade-off, and having a big shared database that all the applications depend on is a trade-off in a number of ways. And one of them is that if any of those applications has a change they want to make to that database schema, they are really restricted, because they know that all the other programs in the company are also depending on that schema, or at least some of the main tables. And so if you've ever seen a big database that's been around for a long time in an organization, and you look at one of the like main tables that everything uses, it's like the customers table or the users table or whatever, you might notice that the first 10 or 15 columns in that table, they're not null, they're required, they have really understandable purpose for being there. And then there's like 50 or 100 more columns have been added on over the years. Every one of them is nullable because some application wanted to store something sometimes. And so they added that for their needs. That is not great, right? And so we would rather be able to have a database that has just the data that is modeled and suited for the application that you're building. But we'll get to that more in just a minute. So in the 90s, coming into the 2000s, this is kind of the go-to architecture that most apps are using. And the really fancy architecture that comes along is layered architecture, sometimes called N-tier architecture, right? And so this basically just meant that you take all your code and instead of having it in one script or C# DLL or Java, whatever, you would split it out into separate logical and sometimes even physical layers or tiers. And the most common breakdown would be the UI, the business logic, and the data access. But the problem with this approach, when it was first implemented, is that it almost invariably meant that all of these dependencies, which are transitive, would go to the database. And so the business logic would all depend on the database at the end of the day, and the user interface would as well. And so this made it really difficult for you to do testing of just the business logic in isolation or just your web layer in isolation. You always had to have a test database. Now, around this time in the early 2000s, testing was starting to become a thing. And Kent Beck published this test-driven development by example book in 2002. And testing in general and unit testing were really starting to take off. It was something I was a big fan of, and I was learning how to do, and I was trying to write these tests for my applications. And I felt like the database sometimes was causing problems for me, right? And as I was writing these tests, I would be able to write some of them, and then I would hit the database, and it would just everything would break because I didn't have a database. And instead of being able to test this method that does this thing, it would blow up and say I couldn't find this database. The database connection timed out or whatever. And that was frustrating, right? And so there was a lot of old man yells at database when we're really just trying to build the software. Maybe we're starting to use continuous integration around that same time. So now even if I do have a database on my dev machine, when I run that on cruise control on a separate machine that's going to be by build server, right? It maybe doesn't have a database or it needs a shared database. And so these were common problems as folks were trying to really embrace automated testing and unit testing in particular. The database was a problem in that it was this dependency you couldn't easily get around without certain techniques. And remember, at the same time, C# development and web development was ASP.NET web forms. So another constraint was that we didn't really have a whole lot of dependency injection and solid principles weren't really widespread at that point. So that also entered into this. But we're getting ahead of ourselves a little bit. So shortly after all the testing books came out from Kent Beck, we also had this idea of this domain-centric way of building software. And Eric Evans introduced this in his book in 2003, which is about 22 years ago. And the idea with this was that instead of having the database be the center of the universe for our applications, we would write applications that were more loosely coupled to the infrastructure concerns that they had, where what I mean by infrastructure is anything that's outside of the process of your running application. All right, and so we would build applications following DDD that would have dependencies on other web services or on the database or maybe the file system, but those would all be kind of, at arm's length, going through some type of an adapter or an anti-corruption layer, DDD would call it, in order to keep it from messing with or corrupting our beautiful domain model of the system that we were trying to build. And this, started to gain popularity here in this time. Now, along with this, it enabled us to build many applications that had their own smaller database because we were no longer trying to have one database to rule them all, that every application talked to and became, the way that they communicated. Instead, this is kind of like leading toward service-oriented architecture and microservices and other things that would come later, because this idea is that every application is its own independent construct that is not tightly coupled to any other application or to shared infrastructure like a shared common database. All right, so a couple years go by after this book's been published, and the first of the domain-centric architectures really start to come on the scene. And the first of these was hexagonal architecture. And hexagonal architecture, as you can see, has a hexagonal shape, right? Because the author originally decided to use a hexagon for the center of this architecture, and so that's where the name came from. A better name for it, which you can also see on here, is ports and adapters. So you can see around the outside of that center hexagon, we have a persistence port, and we can plug in an adapter that then is able to talk to a database. We could plug in a different adapter that talks to an XML file or JSON document or whatever. And there are other ports for other things that you could talk to. But the key point here is that they're all kind of plugging in to our application services and the domain model that we have at the center of the application. And I misspoke. The application services, I should say, are kind of acting as a bridge between our user interface and that core domain logic that's in the center. You can see that up in the upper left. Okay, so hexagonal architecture comes along, and one of the key benefits of this is that it's really easy to test all that business logic and your domain model, which means that if you're building complex systems and they have lots of business rules, you've got pricing rules, you've got systems to say whether or not someone is eligible for this insurance or whatever large complex key concerns that your business has as a differentiator. Now we have a way to test all of that stuff in isolation from the infrastructure, which means those tests can run really quickly and all the time. And that really makes things a lot better in terms of writing software that doesn't have quite as many bugs. All right, so if we look at this timeline that's leading up to clean architecture, we've got client server in the 90s, then we've got testing really starts to take off along with continuous integration and some of the other extreme programming practices that Kent Beck and others were professing. Eric Evans comes out with domain-driven design. We've got hexagonal from Alistair Coburn. And then a little bit later, we have onion architecture from Jeffrey Palermo, which is kind of geared toward ASP.NET MVC, not ASP.NET Core, but the original ASP.NET MVC. And then in 2011, the first article on clean architecture is written. And in 2017, the book with the same name comes out. And so that's this, kind of 20-year period where this was evolving. And you just have to remember that the main thing that we were trying to solve with these architectures was how do we isolate our business logic from all these infrastructure concerns that make testing difficult and make it harder to refactor that domain model as new features come in or as our understanding of the domain grows. All right, so to my experience, this is fairly in line with domain-driven design, although you don't have to practice domain-driven design to use any of these architectures. All right, so then talking about clean architecture specifically, the first rule of clean architecture is called the dependency rule. And the dependency rule basically says that dependencies should flow toward the core project or layer where the domain model is and not toward infrastructure, right? And so there are a few ways that we can implement this, right? If you're a fan of strong types and compile time checks like any good C# developer, you'll see the wisdom of constructing your application in such a way that this rule is enforced by the compiler. And one of the ways that we can easily do that is because of the fact that you can't have circular references in your .NET projects. So what that means is if you have project A and it depends on project B, and then you decide later on you need project B to reference something in project A, the compiler is going to jump in and just say, nope, sorry, can't do that. All right, and so we can take advantage of this to build out a set of projects that will enforce the rules that I just described, the dependency rule. All right, so we're going to start at the bottom. We're going to have this core domain project, and in there we're going to put all of our business logic stuff, our domain model if we're doing DDD. This is going to have our entities. It might have value objects and aggregates and other DDD stuff. but it's going to have just pure C# code, pure goodness that we can unit test with no dependencies. And unit testing is easy because we don't have databases and web services and files and all the other stuff getting in the way. Now, on top of that, we're going to add our application layer, which is usually called use cases in this case. And that's because we can implement that using commands and queries and follow command query responsibility segregation, CQRS. And it's going to kind of work with the domain on individual use cases like add an item to the cart or checkout or things like that. Some of them are going to sound very much like CRUD, like create, read, update, delete operations, but others could be more business logic or in the business domain terminologies, right? But a use case is going to generally correspond to an action a user might take when working with the application. Now, we want to make sure neither one of these depends on external concerns. So we're going to put all the external concern stuff inside an infrastructure project. And we're going to have that project depend on these other two projects. And that's going to ensure that it is impossible for either the use cases or the core project to depend on infrastructure. And then on top of that, we're going to add our web front end. And what that's going to do is it's going to make it so we can have this process boundary between our application and anything that's out of process, the file system, database, whatever. And the only thing that knows how to talk to those things or is allowed to talk to those out of process concerns is the infrastructure project. Those adapters that implement interfaces defined in the other projects are the way that we're going to communicate outside of our application. And on the other side, our ASP.NET Core app is going to be the only thing that talks over HTTP to the front end, right? To the user, to an API client that's hitting our APIs, whatever it might be. All right, and so this is like clean architecture on one slide. Now, if you want to see all the different files and types and things that might go into each of these, I do cover that in other talks and in my previous, .NET Conf talks from previous years. But I wanted to spend more time here on this and then just get into the code. So with that, let's look at some code. We're going to show you some templates. So I've got a .NET new template here that you could run. I just updated it like less than an hour ago to be on .NET 10 and have a bunch of new features. So I'm going to bring up my thing here and just show .NET new clean arc dash, did I say question mark? Yeah. So here is the details on this. And if you want to create one, I've already done it. So we're going to use the Nimble Pros .NET Conf 2 one. But yeah, we can show, like, you just say .NET new clean arc and then -o, and you can say, whatever you want. And it runs in an instant, right? Boom, it's done, right? And now it's created that solution for you. So you don't have to worry about how to create all those projects and folders and dependencies and all that. It just does it for you, all right? And what does that look like? Well, it looks like this. So we've got Aspire in here. We've got the core infrastructure, use cases, and web projects. And we can go ahead and run this. And I probably need to point it at a different browser. I want it to be this browser. That browser. All right, let's go there. Cool. All right, so while it's running, it's spinning up. It's got SQL Server. That's all great. Let's look around and see what is in here. So this is a template. It is not a sample app. So it does not have a ton of stuff in here, but it has a few little things just to kind of show you some patterns. So there's a contributor aggregate, and it's basically just an entity. It's been marked with this iAggregate root marker, which means that only aggregate roots can be used with the repository pattern that I'm using. And so if it had child entities, you wouldn't be able to work with those. You notice that the types here are strongly typed. They're not primitives. So I'm not using strings. I'm not using ints for things. I've got strong types here. That's because I've defined these as their own value objects. And I'm using this library called Vogen, or value object generator, to handle that. And then inside of infrastructure, I've got all my data access stuff using Entity Framework. And there's some Vogen stuff in here that wires those things up so that Entity Framework knows how that works. So when I have the, let's say this name here, I can just say it has a Vogen conversion, and Entity Framework will now translate that back and forth to that strong type. This also has some stuff for email, which I'll show you in a second. And the repository stuff is super tiny, right? And you almost never need to touch it. So that is this EF repository right here. And it's coming from this Ardalis specification library. And so this is basically all you have to do. You don't have to ever edit it. You're not having to have a repository per entity, which is kind of an anti-pattern. Instead, we're going to use specifications, and those specifications are defined in your core project, and they look something like this. They're really small, and they have this little bit of link in them that you would have written if you were just talking to the DB context directly, but now you can use a specification instead, and you can reuse these and test them, and they have a name and lots of good reasons to use them. All right, so the app should be running now. So if we come down to the web project, I have a, where is it? The web project, I have an API right here, and we can check and see if it's working. So we'll list all the contributors, and they're right there. And then I'm gonna just update a contributor here and say send request. All right, and then what does that do? Well, we're gonna come over here, we're gonna look at two things. We're gonna look at our structured logs, and we're gonna scroll down here and see right about here, we're executing the command. This is the handling one, right? So we're handling this event. Let's see, I don't see the other thing I was looking for, but that's fine. And we sent this email. So what does that mean? Well, we actually really did send an email, and I have set up a Papercut Docker container inside of Spire. And what Papercut is it's just a Docker container you can pull from this source right here. It's not part of this application. It's just something I'm using in Aspire. It's literally just defined in the Aspire app host. And it comes with a port 25 listener and a helper here that has an inbox and will show you that, hey, a minute ago, contributor 3 updated their name, right? So if you ever want to be able to test emails, this is something you can just drop right into Aspire, and it works great. So I include that inside of there, inside the template. Okay. So here is, clean architecture. We've got the web, we've got the use cases for things. So contributors, you can do create and all these other things. Then that leans into infrastructure, and that leverages the use cases leverage this core domain. But there's a frequent criticism of clean architecture from folks that prefer architectures like vertical slice architecture, which you may have heard. And vertical slice architecture is basically a rebranding of feature folders, which were real popular when we were building MVC apps 10 years ago. And the problem that is rightly described here is that if I want to add another thing for a contributor, let's say I want to, I don't know, subscribe them to something, right? So I create a subscribe endpoint here in the web project, and then I have to go into use cases, and I have to create a subscribe folder, let's say, which has a command and a handler. And then I don't have to do anything in infrastructure because I already told you my repository takes care of all that. But in core, I might have to come in here and add some stuff to core as well to mark them as subscribed or something, right? And so the issue is that I'm jumping around between all these different projects, and I don't like that. I'd rather just be able to work in one place and not have to be moving all over the place in my solution. And so there's a way that you can do that. And historically, the problem with that, my problem with that has been that if you switch to that approach, which looks something like this, and this has a different domain, but you can see it's kind of shopping cart related. It's got products, and it's got shopping cart stuff. But all these things are just in folders, right? And so now I've got infrastructure with all my data, with all my AppDB context. It's just here in a folder. There's really nothing that would prevent someone from going into one of these features and just directly depending on this DB context. And I don't want that. Like that kind of breaks all the dependency rule of clean architecture. And so fortunately, there's this cool little tool that I found. It's been around for a while, but I only recently discovered it, that lets you make sure that you don't have those problems inside your application, right? So let's just go into something that's in this domain project. Here's this cart, and it's got some code in here. We can say var, db equals new app db context right there. And the thing that you should notice right away is that I'm getting an error here. And that's one reason I'm getting the error. But the other is that there is a tool in here that prevents this thing from doing this. And I think I forgot to update the domain name on it. So let me just fix one thing here. So in this config, yep, there it is. In this config, nsdepcop, which stands for namespace dependency cop, you can tell it which namespace references from one to the other are not allowed, right? And let's see, do I care about that one? No, I don't care about that one. So let's just get rid of those, right? And then rebuild. And what this ought to do, if it's working now, is come in here and there it is. Right, so now I've got the error, right? So ignore the null error, but look, I've got an nsdepcop01 error telling me this is an illegal namespace from the cart aggregate to the data namespace, right? And so by using nsdepcop, you can have your cake and eat it too. You can have a vertical slice architecture where everything is organized by feature, and inside a feature, we're going to have all the things, right? We're going to have the request, we're going to have the endpoint, we're going to have the handler, whatever. You might want to have additional handlers in here. So if you're using mediator, right, we've got a separate command with a separate handler. This can be nice because it can make it so that you can use behaviors for your cross-cutting concerns. But you get it all in this one folder instead of having to have all those different projects. All right, so I'm just about out of time. Let's see if we have any questions. I'm going to throw up before we get done with this. So I had another demo, which was the minimal clean. This is Ardalis minimal clean template. And then I've got these resources for you. The one on the left is for feedback. The one on the right is all the links from this presentation, which I'll update shortly with a few more once this is done. But the other link you can use is this ardalis.com, .NET Conf 25-clean-arch, and that'll get you to these resources as well if you don't want to pull out your phone.